Okay. Uh, Hello everyone. My name is Sarthak and I am a final year student of University of Petroleum and Energy Studies. And here is my colleague Shubham Singh, a cooperative hand in the research work on the deep space communication powered the Space Habitat program. Here is an overview of a presentation. Uh, Here is an overview of the presentation, but all things will take into consideration what causes into what all measures are taken to make the system flow and what are the future plans and how we are tackling currently with the situations using the ways for the communication between the satellite and the space station. Considering the live and the working example of the Voyager. As we know, communication is a thing which cannot be one-sided. It's a two-way communication system for the liquidity in the work efficiency. And this paper is based on the functioning of a space communication with the recent and the running example of the space communication. The mode of propagation is used in the deep space communication, the distance which creates a challenge for the communication, various laws which helps in the study, and the different ways being used to overcome the hindrance and the mode towards which we are turning. The laws which help. The first law which comes here is the Shannon limit or the Shannon capacity of a communication. Is a communication channel refers to a maximum rate of error-free data that can theoretically be transferred over the channel if the link is subject to a random data transmission errors for a particular noise level. And inverse square and another law, the inverse square law. Is it any scientific law stating that a specified physical quantity is inversely proportional to the square of the distance from the surface of that physical quantity. And today, Voyager 1 is the most distant spacecraft from Earth, more than 14 billion miles away, and continuing as on its journey out our solar system. 40 years ago, it made its closest approach to Saturn, and engineers expect that Voyager 1 will return data from interstellar space until about 2025, the upcoming year, when it will no longer be able to power its instruments. And another the ways to overcome it, as it moving with a great speed and a communication lags and the command's expectancy becomes lower than the usual. So the scientists are working on an available sets of communication, the receivers. They are building the receivers with the more surface area of the curvature. Currently, we can see the 70 meter of curvature, 70 meter of are under use, which are making communication of the Voyager up to the satisfaction point. And in the future, as the Voyager will travel the more distance, as well as a high frequency will be required. Another the convenient way being used is the installation of the radio signal antennas at the 120 degrees in a sphere of the 360-degree Earth. And now considering the 360-degree spherical view of the Earth, we have located the three space stations at the 120-degree gap of the globe, which are giving the Goldstone view, Madrid view, and the Canberra view. The locations are specified by the agencies for the better communication with the satellites, and Goldstone, which is situated in California, Madrid in Spain, and Canberra in Australia. To make the problems to a negligible point, the specific places are built up and being prudent decision to the success of the communication. And when the rotation of the Earth take place, either of the two works for the satellite and has the resulting for the space station. When it comes to a long distance call, it is a hard top NASA's deep space network. It is the largest and the most sensitive scientific telecommunication system in the world, which is the DSL. The demand of the receivers as well as the need to be availed by the time as the cryogenic receivers are being under the work for making the better communication update. And going to the question, what are the cryogenic receivers? Receivers for the radio astronomical applications in a particular for a very long baseline, and it is a metal feed is often used to illuminate a reflector antenna, usually operates over wide bandwidths and cooled to a low temperature. The optical when the we can see the for cooling of the LNAs and the feed system components to improve the sensitivity of a DSN receiving systems for the D-Space Commission support was essential and a cost effective. Commercially available 4K GM CCRs can be used to liquefy helium and to interrupt heat leaks to a final stage at a temperature of 1.5 K. The advanced cryogenic refrigeration system will enable to use a low noise amplifier. Use of cryogenic cooler by the deep space network includes both open cycle refrigeration and the closed cycle refrigeration system. The temperatures achieved by the system ranges from 1.5 Kelvin to about 80 Kelvins depending upon the type of a system used. These cryogenic systems are used to cool low noise amplifiers and some of the antennas and feed systems components for the DSN receivers. And I would like Shubham to continue from here.
Thank you, Sarthak. Now I would like to tell you about the optical communication, which is the futuristic thing which can help in Voyager communication. The time is to change towards the optical communication. The New Horizons was sent to capture about the Pluto. The communication lag made the photograph transfer delay by a couple of weeks, and the data transfer rate is approximate 20 hours. 20 hours. Like the Voyager will send data from after 20 hours to the Earth. Optical communication will likely provide the next two order of magnitude of performance improvement. NASA has been developing technology for deep space optical communication. The first demonstration with a spacecraft at lunar and greater distance was accomplished with the Galileo optical experiment in 1992. More recently, optical communication test laboratory was once used as one of the three ground terminals in the Lunar Laser Communication Demonstrator, carried to the moon on NASA's Lunar Atmosphere Dust and Environmental Explorer spacecraft. Operational optical communication in Earth orbit is expected to achieve at least an order of magnitude improvement over the existing RF systems and deliver data rates in the 10 seconds to 100 seconds of GB per second. In order to infuse optical communication into operational deep space environment, we need to demonstrate the appropriate space terminal technology so as to also retire the risk associated with it. Next slide, please. Now, disruption tolerant networking. If a new type of communication is getting built up for the making the high amount of data transfer at a time, as lag is inevitable, this initiative will help in future. Even though DTN was developed with space applications in mind, the benefits hold true for terrestrial applications. Improved operation and situational awareness. The DTN store and forward mechanism, along with the automatic retransmission, provides more insight into the events during communication. Outages that occur as a result of relay or ground station handovers and poor atmospheric conditions, and significantly reduces the need to schedule ground stations to send or receive data, which can sometimes require up to 5 days of planning before a transmission takes place. Next is interoperability and reuse. A standard DTN protocol suite enables interoperability of ground stations and spacecraft operated by any space agency or private entity with SpaceX. It allows NASA to use same communication protocols for future missions. Space link efficiency, utilization, and robustness. DTN enables more reliable and efficient data transmission, resulting in more usable bandwidth. DTN also improves link reliability by having multiple network paths and assets for the potential communication hosts. Security. The DTN bundle protocol security allows for integrity check, authentication, and encryption, even on links which are not previously used. Quality of service. The DTN protocol suite allows for many priority levels to be set for different data types, ensuring that most of the important data is received ahead of the less important data. DTN provides a general purpose network transport layer service that is logically similar to what TCP IP provides for terrestrial internet, but suitable for use in space environment. DTN also provides efficient reliability, security in order delivery, duplicate suppression, and many other things. Multiple applications, including file transfer, messaging, streaming audio and video, on the can all be implemented on top of DTN and leverage its services to reduce risk, cost, and complexity. Now here are all the references are made attached with the PPT for the detailed study regarding the topic.